question 3, we have a crisp production company called Crispy Crisps, highly imaginative name. And we're told that they're doing a promotion and putting a prize in a quarter of the packets. You're also told that no more than one prize is put in any packet, and you have 6 packets in one box. Write down a suitable distribution to model the number of prizes found in a box. Okay, so always define what X is before you write down how X is distributed. X is the number of packets in a box that contain a prize. And X is distributed binomially with n as 6, and the probability of success or getting a prize is 0.25. Okay, write down one assumption required for the model. So you could have written a few different things here to get the mark. You could have said that prizes are placed in packets at random. That's one assumption. Another would be that every packet has a 25% chance of containing a prize. So there's a constant probability of success. Or you could have said each packet contains a prize independently of other packets. Okay, part B next. Find the probability in 2 randomly selected boxes. Only one box contains exactly one prize. Now the first thing I'd do is work out the probability that I have exactly one prize for this distribution, because this is for one box. So I want the probability that X equals 1. That's exactly one prize. You need to use the binomial distribution, the PD function in your calculator. So that's where you go to menu, 7, and then you go to binomial PD. And there you input n is 6, p is 0.25, and then x is 1. And you end up with 0.3559. I usually give probabilities to 4DP if they haven't said otherwise for questions like this. Okay, so that's the probability of getting exactly one prize, but we are looking at 2 randomly selected boxes, not 1. So let's introduce a new variable, which is y. Y is the number of boxes containing exactly one prize. Okay, so y is distributed binomially. It's 2 boxes that we had selected at random. And the probability of getting exactly one prize in one box is here. Okay, so we are asked to work out the probability that only one of them has exactly one. So we need to use the PD function again on the calculator, but you obviously have to change your n and your p. And that's the answer that you get. Okay, so part C, find the probability that a randomly selected box, so we're now back to one box, which means we're looking at the X distribution, contains at least 2 prizes. So for part C, we want the probability that X is greater than or equal to 2. It's got to be 2 or more if it says at least 2. This time we've got to go to 7 on the calculator and binomial CD. It's a cumulative probability that we want. But as you know, the calculator only tells you less than or equal to probabilities. So we rewrite this inequality as 1 minus probability X is less than or equal to 1. And when you put in your n is 6, p is 0.25, and x is 1, you get the probability of x less than or equal to 1, which is this. So 1 minus would give you 0.4661.